Bismillah ar-Rahman ar-Rahim. Sorry. So we have here an exercise. Let's get started. If we have A, we suppose that we have A, B, C, D from R, such that C is different of 0 and D is different of 0. First of all, we have to prove that if AC is equal to BC, what we can say about A and B. This implies that if we times both sides of the equation by C minus Y is equal to B, C and C minus Y. Since we have an axiom of the multiplicative axiom identity, this will equal to 1 and this is equal to 1, which means that A is equal to B. For the second question, this is the first question. The second question, if we have A 0, this is equal to 0. How we can show this? We can write AB, this is equal to AB, and this implies that AB plus minus AB is equal to 0. Then we have A times B plus minus B. We use distributive operation with respect to additive, multiplication with respect to additive 1. This is equal to 0, but this from the axiom additive identity, this is equal to 0, which means that A times 0 is equal to 0. The next question, how we can prove that minus A is equal to A. One has, so we have I plus minus I, this is equal to 0. So we add I plus minus I plus minus I. This is equal to minus A. But this element and this element are opposite, which means that A equal to this is equal to A, which implies that A is equal to minus A. For the next question, how we can prove that minus A, this is equal to minus A. What we can do, we have A, this is equal to 1 times A. Then we can write A plus minus A equal to 0. Then we have 1 times A plus minus A equal to 0. What we can do, we add in this stage, we add minus 1 times A plus 1 times A plus minus A. This is equal the first one, minus 1 times A. But this element are equal to 0, which means that minus A is equal to minus Y times A. We can prove this using a next result. We will treat it in a few minutes. the fourth equation, how we can prove that minus 1 is equal to c power minus 1 is equal to c. We know that c times c minus 1 is equal to the identity by multiplying both of the sides of the equation by c minus 1 times c minus 1 minus 1, and this is equal to c minus 1 minus 1. But this element is equal to 0, which means that c is equal to c power minus 1 minus 1, so the inverse twice. For the next question, we wish to prove that for all a and b from R, how we can prove that I times minus b is equal to it's equal to minus ab, and this is equal to a times minus b. What we have a times b plus minus b. This is equal to 0, and at the same time we can use the axiom distributive of the multiplication on the addition. We will get a b plus a minus b. This is equal to 0. So if we add minus ab to both equations, so we will get minus ab plus a minus b. This is equal to minus ab. But we remark that there are opposites, so this is equal to 0, which means that minus ab is equal to a times minus b. And we can deduce, sorry, here we have minus a, and here we have b minus a times b, and we can deduce this one from this one. We proved this equation, so about this quantity with this one, we can just change a by b and b by a, and since the multiplication is commutative, so we will get it without giving another proof. The next question is about how we can show that how we can show that minus a plus minus b is equal to minus a plus b. In this stage, we can just remark that for example we have a plus minus a plus b plus minus b. This is equal to 0 since we have opposite number. So we can add at this stage, we can add what? So we can rewrite this formula as a plus b plus minus a plus minus b. This is equal to 0, and at this stage we can add minus a plus b plus a plus b plus minus a plus minus b. This is equal, since we add minus a plus b, so this is equal to minus a plus b. But we can easily remark that this is equal to 0, so this is equal to 0, which means that minus a plus minus b is equal to minus a b. The next formula how we can prove that minus a minus b, this is equal to a times b. So what we can propose here as a solution, we have for example this formula from the previous one, from a minus b equal to minus a b. From this equation we get from this minus a minus b, this is equal to minus a b, and we will repeat the same operation here, since we have minus 1 times a times b. Since it is associative, so it will be equal to minus 1 a b, which is equal to a b. This is a way. We can use another way, so we will provide another way to show this. Starting from this, what we can write, so we can write a b plus minus b, this is equal to 0, and here we have ab plus a minus b, this is equal to 0, and we add what we can add. We add both of the equation a b, we add minus a b plus a minus b at this level, this is equal to minus a b. From this side, this is equal to 0, and from sorry, it is not good, this is not good, so I will repeat this one, and I will keep it in the video. So we can try by writing minus a times b plus minus b, this is equal to 0. This is equal to 0. And in this side we can write minus a b plus minus a minus b, this is equal to 0. And this one, using the previous one, will be equal to minus a b plus minus a minus b, this is equal to 0. And we add to both of the equation plus ab, so we will get ab plus minus plus minus ab plus minus a minus b, this is equal to ab, which we add, and they are opposite, so they are equal to 0, which means that this one is true. So here we have 3 ways, 1 wrong and 2 true. The next one, how we can prove that a over c for a and b from r, c from r, c different of 0, and d different of 0 for sure from r. How we can prove that a over c times b over d are equal to ab over cd. So a over c, we can write this as ac minus 1, and b over d, we can write it as bd minus 1. So ac times bd over D. This is equal to AC minus 1 BD power minus 1. And using the associative operation, we will get AC minus 1 BD minus 1. And this is actually equal. We keep this one like this, and we times it by CD, and we cancel CD by CD inverse. Since we have commutative associative operation, this one will be cancelled with this one, and this one will be cancelled with this one. So we keep what? We keep AB times CD minus 1. And this actually is exactly, it can be written as AB over CD, which ends the proof. How we can prove that? A over C plus D over, how we can prove that A in the same condition, B over D, how we can prove that this is exactly AD plus BC over CD. We start from this one. So we have AC minus 1 plus BD minus 1. And in this case, we can times it by CD, both of them. So we can write AC minus 1 plus BD power minus 1 by CD. So CD here by CD minus 1, or power minus 1, the inverse with respect to the multiplicative operation. And this is what we will get. We get C with C minus 1, we cancel them, and we keep AD. So we have AD, and this one with this one, we will cancel D with D, and we keep BC plus BC. So this is cancelled, and we keep CD minus 1. Since we have this we can write it as AD plus BC over CD, which finishes the first exercise. See you at the next exercise.